welcome for the students to the university and the course in case you've started your studies from now with us, and also welcome back for the students who have already started with us before, because I know we do have two different groups of students. Okay, so advanced construction systems is the subject I will be looking after in teaching you. And maybe before, because it's just week one, how many are you with me now online? Things will be announced and we will send you very clear emails. There is a large possibility that the lecture time will be changed. The day will stay as it is, but the lecture time, there is high chance it will be early in the morning, whether 9 a.m. or 8 a.m. That's from week 2, right? So there is a, just to let you know, just to work out with some other subjects I'm delivering. So that's just the first thing, but I will carefully announce that to you and let you know by the LMS system so nobody will miss it out. But just from now, put it down that there is a possibility, a very likely possibility for this lecture to start early in the morning, whether 9 a.m. or 8 a.m. Mondays. Okay, that's starting from week 2. That's the very first thing I want to tell you. The second thing is, I think it's all gonna come up while I take you through the basic lecture notes. Today is, I know it's supposed to be an introduction, but I've just put a topic here, which is not our main topic to talk about in terms of construction. I know you all coming from undergraduate, like you finished undergraduate studies or practicing engineers, and you should be on top of building reinforced concrete sections, which is the topic of our introductory week. The main topic we're going to be talking about and the projects and the group work activities will start from week 2. Today, I just want, there are going to be some connections between what I'm going to be teaching you today and some of the topics like advanced methods to construct composite slabs, right? Some skills we're going to need to be used or remember from the topic we're talking about. I just like to talk about this topic because just to know about the local market of constructing concrete slabs. So it's got a couple of pages there. So you may see they have a lot of pages, but it's all about pictures and examples. So it should be fine. Okay, but before I get into the details of the construction techniques for frame building, I will introduce you slowly to the subject. If you have any questions, in case I missed that chat box, you can always unmute and ask. Feel free, really, to do that. Or you can raise your hand, whichever method you use. Yeah, to make sure things are all good. Before I start, anyone got any point to raise or issues to talk about?
No.
No one was there. Was that question to me? There is like in the chat box, or that was something else. It is start or no? No one was there. I'm not sure what does that mean. But okay. All right. So let's see what we have there. Yes, this is me. I will be teaching you the subjects and I'm coordinating it. Beside lecturing at La Trobe, I've practiced structural and construction engineering in the industry. And the examples I will be sharing with you will be definitely things that have been done outside. So as you're gonna see, even in the project, I will let you work on in a group. It's the aim from it is to simulate a real world scenario. So 50% of your mark will be coming from uh, the the major assignments we have over the semester, and you're gonna be like the first one, you're gonna be working on steel structures. The second one, you're gonna be working on concrete structures or composite structures, and you will be able to learn just the real process. It's not about the methods and the details, it's also about living the environment. I won't be acting really as um, just the lecturer in the subject. I will be acting as a client or the architect who's working on that project with you, and you're going to be marked on this regards. Um, yeah, last time the subject was delivered, students have worked really very well. But you just need to know in depth the details we are talking about, and you need to be proactive with us. Otherwise, things may be really difficult. All right. So basically, we're gonna go through the practices. Yeah. So it's not only about if we're gonna build this, we put that on top of that. No, it's about the practice. What's happening really in the real practice, what concentrations you need to have, what decisions you need to make, and the timing of that decisions. You're going to go through that in a systematic way where things will be easy to learn and also to study, whether for your exams or to apply outside. So, put it this way, the projects we're working on, it's going to teach you terminologies. It should teach you the you can put them on your CVs and resumes, because when you go and put your resume, you're gonna write which projects you have been doing, how large they are, what challenges you have there, and that's what you're gonna be doing in the two projects you're gonna be working on. You're gonna have challenges, you're gonna have terminologies, and definitely you can use it in the right way. So what I'm trying to say, you won't be working on textbook questions. You're just going to be working on real projects. So with practices, the materials developed, we're going to be talking about steel, concrete in different advanced way, like composite structures in different ways. Basement developments. There's a lot of basements you see around. They are not as easy as you see them when you park your park underground in the city. There's a lot of buildings with basements. There is 3-4 different ways to build those basements. They have their own challenges. Okay, you will be exposed to the different types, and one of your assignments will be asking you to detail everything and show how things will be built. All right, we're gonna work on medium and also talk about high-rise developments, commercial or non-commercial buildings. Okay. I will expose you to a number of examples, and will also let you practice on something similar to them. I know some of you will ask, what about the final exam? We'll come to that later on. So I'm talking here, when I say assignments, one of them going to be 30%, one of them, 25 each at your assignments, and then we have our final exam. You will be engaged with the technological process, and especially, like, for example, those board piers, the retention systems, the retaining walls. They have special equipment, special construction techniques and processes to consider and know. All right, like if you want to build a pile or a footing in an area next to the CBD, which got a lot of water table is too high. How are you going to put your concrete when there is water there? You have to use a product like bentonite to help you with that. How and when and all these kind of things you will be exposed to. Okay. Yeah, piling system for basement. I talked to you about it. Retention systems means retaining walls. Yeah. Industrial buildings, which is the portal frames, you're going to spend 3-4 weeks about that, and you should get some good skills from there. Ground slabs, we're going to spend a week talking about industrial ground slabs, their construction secrets. Yeah, they are different than the footpaths. When you're going to go walk around, you see footpaths. Footpath is just a slab, or like your driveway. It's just a slab on the ground. Yeah, it's a RC building. Sorry, RC, it's reinforced concrete slab. But how the industrial floors, which carries a lot of heavy load, are different from this. This is what you just need advanced techniques to build such components. Precast, yes, we have very nice topic. I find students really like it and well engaged to it, and did have things to, like, when you're gonna go and talk to builders outside, you tell them about precast panels and how they built and the detailing. And if you know all these things, you definitely you will be able to talk about them. Another famous construction, pre-stressing applications, whether pre-stressed, post-stressed, you will be able to understand the construction skills behind all that, how it's done, how it's built, why this is done this way. Yeah, to some limit, definitely in this area, civil engineering, construction engineering, we always learn from the site. Yeah, so we're going to give you the background with strong industry-driven flavors, and hopefully you can compete with them and do well outside. And what I'm trying to say, you have to learn more. It's never enough. Yeah. So pre-stressing concrete, we will expose you to the construction challenges there. What else? Hybrid composite structures. Yes, we will talk. So when I was saying reinforced concrete, it's kind of connected to pre-stressing, because pre-stressing concrete, it's concrete, but the technology we use is advanced. We use cables instead of bars. Composite, it's another advanced method. We use mechanical techniques to make a component composite, not only concrete. We connect it with something else. So you will be exposed to all these kind of topics and construction methods, right? So how time commitment, contact hours, you go 2 hours for lectures, the ones I'm talking to you about now. You can see our lecture notes can be really lengthy, right? Some of them got large pictures, but the way I'm delivering them to you, it's kind of industrial. I'll talk with you as we want to build a project together, not really just reading what I see here. You're gonna see, and I put them there. Someone will ask why we have all those materials. They will help you to give me the right answer for assessment 1 and assessment 2. That's the answer. All the information are given to you in the lecture notes. They're gonna be the key elements you need to know to get ready to first answer your assignment 1 and 2 with your teammates. Number 2, to get ready for the final exam. Final exam will come only from the lecture notes as well as the practiced assignments and workshop questions. Okay. So I strongly suggest you to attend, ask, watch if you couldn't, the videos, because things I found it in the past was really very useful, and students get well engaged with it. So 2 hours, which we started the first one today. As I said, next week we may have our lecture from early in the morning. Workshops. Now, the workshops, they are 2 hours each week. They are blended. We're going to have them 50-50 face-to-face and online. So again, for the lectures, they are online, as you all know, and they're going to be typically online, whether today or next week if it was early in the morning. The workshops, they we have group in Bandura and a group in Bendigo. 1 week gonna be face-to-face in Bandura, Melbourne, and another week, or the alternate week, gonna be in Bendigo. This week, as per my message to you, we will start our face-to-face workshop here, but I will be connecting to Bendigo group. So you still have the room booked. You're more than welcome to, or if you want this time, you can stay from whatever is convenient to you. But until you get grouped, or until I see you, I'm talking with now about Bendigo group. If you want, because when I'm gonna be doing the workshop on campus in Melbourne after tomorrow, Wednesday, I have developed special channel in Microsoft Teams to also connect with the students in Bendigo. And you may do it from campus or whatever you like until I meet you in week 2. And maybe what I'm trying to say, from there on, you can always come to that room because it's booked to you if you like to group with your friends, because you're going to be working on a group. Now, this was about the arrangement. In summary, the workshop is going to be delivered blended, which means face-to-face and online. I know face-to-face just can help you to view if things going to be better for you to understand how things are done. I know people still like, even with face-to-face, they like to have more meetings online. That was the case last semester as well, which I'm more than happy to book other times. I'm available also other times if with your groups want to talk with me about solving things. But for now, this is going to be the delivery. We're starting as per where I've showed you all that. Let me just open the LMS, which I also would like to introduce you to. So I'm just here bringing the LMS on the screen. And I will put myself as student. So let me just go to the subject first. This is your subject. And you should see the subject like this at the stage, right? Now, what I'm trying to tell you, inside those grid, which I ask you to look at, inside, click here. This one, start here, will talk to you about the intended learning outcomes, which I've already briefed you about, the different construction techniques, etc., etc. We will, so you're going to be able to evaluate and the factors influencing construction processes. And this is going to happen not only for one type of construction development, it's going to happen for, I can say, up to 5. So as I said, you got steel structures, concrete. The concrete is divided to pre-stressed, composite, precast panels, piling systems, portal frames. So these are the main, and the industrial slab. So it's really rich with the different areas. And we did find students are engaging with it. It's not only one area to look at, it's different things with different construction problems. This is here, distinguish between various structural systems. If you successfully go through the subject, you will be able to get to such level of understanding. Evaluate the process of alternative construction systems. Yes, we will take you through different ways of building walls, different ways of building the concrete slabs. It's not only done by bars. There is post and pre-stressing, as I said, composite. You're going to be working with drawings. Yeah, you're going to be having authentic real world drawings, engineering drawings, combined with architectural drawings, and working with them to solve problems. It's not only a textbook questions to figure out an answer, right? So it's going to be strongly technical, hands-on subjects, which I can tell you, students who really get busy, don't attend, don't know. I have students who coming to me, they fairly say, I have issues with the terminologies. Well, that's where you should come and ask me on time. You can't just leave it 1 week from the final exam to get it all. And remember here, with as you may all sense, the assignments are group, but when you're gonna submit your work, I need to know which students did what. Okay, so just to check your teamwork activities, because it needs to be equally done. I do have groups where they say Mr. X supposed to be this, and nothing was returned. Okay, this should not impact the whole group. So just pay attention to group. And this is, again, what's happening in the industry. You won't be responsible. You're gonna be a team of 20 people to work together. You can't do it by your own. It won't work. When you're going to be working on the projects, you will be required to draw things. You are required to do some estimations, research, detailing, and you're going to be working collaborating together. Okay, and so these are the intended learning outcomes, and definitely it will be met with what we talked about. So assignment 1, 25% is to do with steelwork, steel structures. Assignment 2, 25% with it's a very engaging, it's really nice project, which gonna let you know about retention systems and some concrete detailing. It's really engaging for you. Final 2 hours exam. The 2 hours exam. If you understand what we're saying in the lecture notes, you should be on top of it. Yeah, you should be on top of it. So that's to do with your 3 assessments. And yeah, that will cover everything within there. So what else? Okay, pre-materials, what you need to have. The materials I supply you with over the weeks should be enough. The materials, which are all provided to you here from week 1 all the way to week 12. You always gotta have materials that you need to read and understand, and I'm telling you this from now. The engineering drawings that we are talking about and I expose you to gonna need to be carefully understood, because that's what you're gonna be examined for. I will not bring anything outside what we've been practicing together. I'm saying it from now. So the engineering examples and drawings that we're going to be exposed to from maybe the first workshop after tomorrow or next week, they are the ones you need to understand. And I will never, in the final exam, you will never be asked something outside those skills and details, right? Because those are rich enough with information I want you to learn. Okay, so I will be confirming this as I go over the weeks again, because okay, let me tell you example. When I'm gonna give you assignment 1, I will simply ask you about, can you please tell me, let me look here. Can you please tell me, for example, where I'm gonna teach you all the details, how we connect the portal frame elements together, right? I will teach you, let me zoom in, can I zoom in? Yeah, that's good. So I will teach you all about the challenges and details to build a portal frame, steel structures like this. There is a hinge, there is a column, there is a rafter, there is purlins, there's gills. I know these are the terminologies we're going to use and use and use. So I will, assignment 1, I will ask the students to detail or annotate for me the connection between this and that. Some students, they just Google search something from somewhere and put it on their sheet and tell me this is the answer. It's absolutely wrong. Because maybe they did not even attend my lectures or the workshops, so they don't know what we're talking about. Yeah, no, in my assignment, I've given you all the real pictures, and you're supposed to be searching for the correct picture, then annotate things and detail it in the right way. It needs to be related to the project. You don't need to Google search, find for me a portal frame connection. And they ended up, I can show you such examples, which is really funny. But this is just an example. The drawings I'm going to give you, they are about 4 to 5 projects. You're going to be using, they got a lot of knowledges and details and construction skills. You will be asked within those projects, full stop. I will not go find another challenge and ask you about it. Again, the ones we practiced and I talked about, and I made sure we practiced it in the lecture and the workshops, they will be the ones that are going to come to you in a final exam. If there are some details, like because I want to give you the full picture, maybe I kept everything on those drawings. There are maybe connection details which is we don't talk about. I will not bring. I know that. Everything is recorded, and I know what I taught you, and I know what I didn't teach you, and so if you following with me, you will. I see the students really get on top of the subject very well. Unfortunately, very few people fail the subject because they were simply just don't know what we're doing, and they busy. They just not really following with the curriculum, which was a weakness. We try to support the students. I know they may be engaged with something else. We try to support students as much as doable, but you can't. Some students really don't answer nothing or really don't talk about what we're talking about. Sometimes in the assignments, they go and get things from the internet. I don't want you to give me a literature review about portal frames. No, I want you to build something. Okay, and 95% super happy about it and do it very well. I just want to have that 90%, 100%. Yeah, so that's just a message. Any questions about the workshops? No, final exam is not open book. It's done in a way where I will ask you a question like, can you tell me the process of going back home? Do you need a book to tell me that? You're gonna tell me, maybe now you are sitting somewhere, I don't know where you are. Let's say I'm sitting in a coffee shop. I will say, I'm gonna walk to the bus station. I'm gonna get the bus. I'm gonna wait for bus number XYZ. I'm gonna get into it, get to the, so I don't need the open book to tell me that. I'm working with you for 12 weeks, talking about different construction components, different construction methods. If you did them with me, if you fully participated on the project. When I say participated, don't only do your part. I know it's a group work, maybe a group out of 5 students. Don't, like if you were responsible on drawing, on drafting something or sketching things, don't do that part and say goodbye. You should have time to also recheck what your other teammates did. So make sure you work as a project. If you do, so what I'm trying to say, you should know all the skills. I want you to learn from the assignments 1 and 2. If you did all that, if you followed with me, you got the idea. And I will not ask you memorization question. Like I won't ask you, list to me how many the type of, no, it's not like this. It's just construction techniques and methods. I may in the final exam give you a picture to annotate. What else you want? Do you need an open book to do that? No, you should know that from the weeks we spent together. Yeah, I may give you this picture and tell me, I may give you this picture. This is going to be one of your questions worth 5 marks or 7 marks. I can tell me annotate and name all the structural elements you see here. And that's question A. Question B, write down the sequence for constructing them. So this is a hunch. This is a hunch. Yeah, this is a hunch. This is a rafter. This is a purlin. This is a column. Because I will let you know all that. You will know all that. Okay, and a girth, there is no girth in this picture, and then you just need to sequentially list them, which one you're going to build first. This one is a bracing element. See this X here? It's a bracing element, right? So things, but I may ask you to detail the connection between the brace. So that's really the construction techniques, and students typically do very well. So no No open book. Any software need to be learned to do these assignments. Software in terms of, I just want to remember, was there for the subject? Not really. No, no. You don't need a software to learn this subject, but you need to know how to type things and get things done. Yeah. Any other questions? Recommended a book for this subject. You're going to be provided with all the materials you need. You will be provided with all the materials you need. And I can tell you, I would the material, the books that I may have, I will list for you, give you, well, okay, put it this way. Or it's actually the answer is there. There is no book because the books may be not local. And what I'm interested in, or this subject, is expose you to local materials, and as well as a lot of industrial materials. For example, student resources. You see this section here? If you click here, I will already give you a lot of books, which is available for people working in this industry. So there is a lot of reading materials you will be asked to use. Not one book, there are many books. So I know you asked for one. Just relax, you have a lot already. Some of them are books, some of them are technical details which you will be. Now, some students gonna take a deep breath and tell me, do I need to study all that? And you're telling me it's not open book? No. You will be asked from what we practice together. And those 95% of the students who successfully do very well in this subject, or I see them super engaged in this subject, they just follow this trend and get very well, right? Some of the topics, I will open one of those documents and show you how to use it, right? Like, for example, we need to build a composite slab on a bond deck, metal deck. There is a technical document or book from a supplier telling us how to go and select the right size. And I will do this practice with you in the workshop or online. If I do this, expect you're going to be asked this question. There's many other books which I just give it for you to save it in your library. I can tell you in this industry, people in each project, every month you're going to be working with a different document as a construction manager or site or engineer, or as or construction engineer. Yeah, you always, like, if you're going to be building the panels, the precast panels, you have to go use, and I gave you some of those documents. You have to go and use your precast panels documentation, regulations, standardizations, and I will expose you to that. If I intentionally want you to practice something, because I will ask you about in the final exam, I will do it with you, and I will hint for that. All right, so one of those weeks is about precast panels, and there are documents which give you guidance to do that. All right, there are some documents which I just want to give them to you because they are really um, uh, good to have. Most of those you can find them by the internet, but I just simplify things for you. And this library will keep growing as you practice. Okay, maybe tomorrow like one of the topics I'm going to teach you, advanced walling system. It's called architectural construction or architectural walling system. You need to open its own build, construction documents to know how things are built. And I will let you see that. So I don't practice it with the students, but I tell them about it. So in this case, you don't need to know that for the final exam. So now, yeah, so you already are set with the recommended reading materials. Another question. Another question, all the videos of the lectures and PDF files will be provided. What you mean provided, in the exam or for you? All the video, all the lectures, right? The lectures will be recorded and provided to the students, and the PDFs are there already. The lecture notes are already there. All those drawings that we're going to be working together, they are already there, and I will use them there. Yeah, they are all there. Workshops will not be recorded unless it was online for you. Again, workshops will not be recorded unless the workshops were meant to be online for your campus. So this week we have a workshop on campus in Melbourne. They're gonna be a live opened to Bendigo group only. You can Melbourne students cannot access it. So how is this happening? I will show you that. I will show you that. If you bring on your Microsoft Teams, actually not this one, there is another page in Microsoft Teams. Let me open it. I think Bendigo students already received something about this. What I'm trying to say here in Teams, this was actually your icon, Advanced Construction System. That's where are you now in this lecture. This icon here, it is for online workshop for Bendigo students. Only Bendigo students are able to access this. The recording will be same thing, saved and recording, and they can access it whenever they want. However, Andorra students, when they are expected to come to campus, they won't have access to this. Okay, workshops are really dynamic and active because during the workshops, I will be spending 50% of that workshop giving you support to work on your assignment. Basically, I will be solving the questions to you. Okay, so over your workshops, like I will start solving your assignment one. Now, this coming workshop, I will introduce you to your first activity and assignment, and I will start solving the questions. I like showing you how to do it. So that's where I'm expecting you guys in a group to come up with high quality submissions, right? Bendigo students for this first one, now this workshop, Wednesday, I will group you. I will show you how to get grouped and take you through that to know your team members and then start meeting with them. Same thing in week 2, I will go face-to-face to Bendigo and students, it's your choice, guys. In Melbourne, you can come to the room. It's booked for you. You can come to the room and engage with me online from campus. Okay. Or you can meet together anywhere and just attend. So usually the first half of the workshops will be for me to talk and give you support in answering the assignments. And people do very well with that because, you know, the assignment is not as easy as one answer. You have to do drawings. You have to think about buildability details. And again, the failing students, typically, they are the ones who are used to a research subject. Don't think that you're going to need to go Google search how to build a portal frame, and it's going to be wrong. It's not a textbook question. Okay, you're gonna know what I'm saying as you work with me. You know, it's like working in a real project, and you cannot do it by your own. You need an engineer with you to support you there. Did I answer all your questions, guys? There is another one. For assignments, how many students per group? Between 4 to 5. I will confirm that Wednesdays. It's up to you. If you know people you like to work with, what I'm gonna do, I'm gonna create rooms, like maybe 10 rooms by Wednesday. They're going to be 10 rooms, and simply students need to jump into those rooms. Each room can house 5 or 4 students. I will determine that number. Okay, so if you want to make your own decisions, then once the links, I will open the links by the start of the workshop. So Bendigo students, we're going to be communicating online, and I will be there sitting with my laptop online, and I will, you're going to be there through your channel as well to take you through all, the same details and so on. Any other questions? If you like to unmute and ask, please do so. Okay. Intended learning outcomes, which I took you through already. Okay. No, this is not up to date. Don't worry about this slide. Yeah, as I've already mentioned to you, this is now Wednesday. I will change it and upload it. And this is now Monday, but this will be changed, as I just mentioned to you. Okay. I will update this slide. Now, let me go back to LMS because some of you may still have questions there. I've already shared this with you. So after you go to LMS, I strongly suggest you to read this part, start here. And I've already took you through the subject learning intended outcomes. You can click on start here book. This one kind of take you through the subject learning guide. This guide tells you how the subject is running, the coordinator, all the detailing, which is similar to what we have in the handbook, and also similar to what we have here on this document, which I will use. So one of the silos, which I've already covered for you previously in the other sheet, and what you should learn from the subject. The other important part I want to show you, it is the learning and assessment schedule. So the lectures are online from this week all the way to week 12. As I said to you already, workshops gonna be blended. So online for Bendigo week 1, on campus for Melbourne week 1. In week 2, it's gonna be on campus in Bendigo and online in Melbourne. Week 3, things will so it's alternate model. There are some submission due dates for your assignment one, which I will be. So the assignment, it's not only something I will give you, like this Wednesday, I will talk to you about the assignment and leave you with it. No, each workshop I will be solving it in part, in an indirect method. So you're gonna know what I mean. I will let you work with me on it. It's like when you're gonna be briefed about a project to work on, you will be shown what to do. And then they're gonna be skills for you to apply. Okay, so I don't want you here to do research. I know you're doing this in many other subjects and you're super perfect with it. I want you here to show me how to build things. Okay. So this is important table, which you may like to reference and use it just to know where we are at. The rest really just some important, as one of you asked about the reading materials. You have a reading lists that I've already exposed you to, which the reading materials, which I already have for you. I think there is that's I think one of you asked this question. Is there a recommended book? We do have one here for you listed. However, what you're going to be assessed for and asked for is the techniques that I'm sharing with you. So you can have this in your library, but if what they're going to show you are in line with the question and they can defend your answers, please use them. right? But the other textbook, they're going to be supporting you. Is there any question? Any question someone like to ask? Okay, so as I've already, now this is, oops, this is correct. This is will change. It's gonna be mostly pushed to the morning. So this is Wednesday. What was the time? Can someone confirm? Do you know your workshop time? That's right. Yes.
From 12 to 2.
Yes, it is 12 to uh, 2. No, that was a different subject. Your subject is here, Advanced Construction Systems. And you can see I've already set a link for our Bendigo students because they're going to be accessing through here. And it is 12 to 2 p.m. All right, so I will be updating this information and
शाम का
things
रख
will
लांगे
be confirmed.
फिर
Okay, so next. Yeah, that's self-explained. The first assignment, the first group work assignment, which we will start on Wednesday, it is now it is about steel framing structures, and its due date will be again confirmed. I will talk with you about it because you know as you're going to be supervised, I just want to make sure you don't need to wait until week 3 or week 4 and you start working on it. Its quality going to be very poor, and it's also a recipe for failure for the final exam because if you once we pass week 3, I won't be talking about steel anymore. I will be talking about many other. I will be talking about industrial slabs, then retention systems, then composite slabs, then precast panels. And yeah, we won't have opportunity really to, if you did your assignment very well, you learned what we're doing. This is the best way of, it's like a real world. You cannot build something in the wrong way. Yeah, you have to get it right from the start. Okay. So you've got the first assignment, second assignment, 25%. They are group based. I know this is individual, but it is grouped now. This is a group as well. And that will give you your 100%. Okay, how we learn the subject, which I think some of you already asked us this good question. Lectures, yeah, attending them, or just in case if really was not doable, listening to the lecture, watching the video, and asking as much as you can. Construction drawings, yeah, that's what really you're going to be working with. You're telling me you are doing construction, you need to be working with drawings. You know, this morning I was teaching structural design subjects and I was showing the students structural drawings. I'm not sure if I have them open. I'll show you too many later. Let me open them again because I closed them. Or let me open different examples here. Where are they? Let me go back to this other subject. I'm not sure if this is the one, but let me try. Because I don't want to show you your drawings. So this is just, I was showing to the students structural documents like this, and was telling the drawings, the students that architectural drawings usually can be understood by different people from the community, because usually the architect is doing them for general, for public use. You know, everyone, a lawyer or whoever in the industry want to build a house, and they should talk with the architects to know how to do them. But engineering drawings, no, you've got only professional people to know how to use them. Some clients, they may ask. So what I'm saying, I'm gonna be exposing you to like this is industrial slab here we're talking about, but your projects are a bit more complicated than this. You're gonna be exposed to many engineering drawings or even architectural drawings. These are architectural drawings for, this is one of the main projects you're gonna be doing. These are architectural drawings. What I'm saying, normal people can understand architectural drawings with some thoughts, but structural drawings, which I closed it and I just need time to find it. I don't know where is it for this project. Which subject I was talking about? Yeah, this one. Is there any people from you who was practicing engineers or worked on it? Are you all engineering students or? Yeah, here we go. So as I said to you, these are the architectural drawings for a school development, which it's going to be one of your projects. You're going to be practicing on and understanding buildability and feasibility challenges. Okay, see, as I said, the architectural drawings, they are mostly to do with the look, etc. But structural drawings for the same project, it looks something like this. Yeah. So can someone tell me what's this about? What does this show you here? Don't tell me elevation. I know elevation is written here, but elevation for what?
These are the columns from the side.
Thank you for trying. Any other answers? Thank you for trying. Slabs. Any other answers?
There's the drawing of a truss, roof truss.
Thank you for trying. Any other answers? They are piling. Perfect. Well done. It is, they are piles. Yeah, they are piles. That's it. They're telling us how piles are built and they are anchored piles. So that's what I'm saying. I was stopping at this slide, and drawings. They are the key elements to work with in order to do your job and get paid. You are in the construction industry, whether you're going to be a manager or a big boss or that, whoever, you have to debate with your client or the engineer who did it or whoever about the drawings. That's your language. Okay. So you need to understand it. And this subject gonna let you have very good experience there in doing that. So please, they are hands-on assignments. Hopefully this time I won't see a literature review about concrete. You giving me, yeah, some, it's not a report, it's engineering documents I want you to work with. Yeah, there are piles. Set of images. Like assignment 1, I will give you a lot of pictures taken for a project and can ask you to annotate and detail the names. Yeah, as a practicing construction engineer, you need to know the terminologies, the names of the connections, Sometimes I ask you what type of actions we have there, some engineering thoughts you need to put there. Yeah. So we're going to be working on images, drawings, lectures that I'm delivering with you every week. You have to understand them, the lecture notes, workshops. Yeah. They are the environments which will facilitate the delivery of these ones. And the good thing with which I found really students get super engaged with is I will help you to solve those assignments. Okay. Reading materials, as I said to you, to some limit, and as per my instructions. There are reading materials that I'm giving you in a particular week, which I just want you to know about their existence. But don't expect me to ask you about them in the final exam. No, no, no. If I have used one of those reading materials in solving questions and figuring out a construction process, then yes, expect it to come in the final exam. If this is clear, so I think people should not ask me this again, because people do ask how we can get prepared to the final exam. It's 50%, and I'm just telling you this now. And this is your team, maybe 4 people or 5 people will figure this out. Yeah, you need to have that peer discussion. If you're gonna submit your work, I will be asking you that students have to put at the top of your, so if one of you gonna be answering questions or doing part of the project, I need to know who did that part. Maybe you give me a summary page or a table saying Mr. X done these sections, Miss Y did these sections. So I need to know those names, yeah, to make sure there was a teamwork. If I find one of the qualities are really poor, then yeah, that means the others won't be impacted. Okay. Any questions? Okay, let me give you, I'm supposed to give you 5 minutes break. You need 5 or 10 minutes break. Yeah, no preference. So let's meet again at 10 past 5. Just have a quick break. Yeah, you want more? Okay, let's meet quarter past 5. Yeah, then I will continue over the slides. I know I've slowly gone through the first sheets because I just want you to understand how we're going to be working together. Because if you misunderstood the main learning techniques, that's the challenge. All right, so let's meet 5:15, and then we continue the slides and take it from there. See you then.
छेड़खानी नहीं की ज्यादा।
मैं तो लैपटॉप पे हूँ ना अभी इसलिए। कुछ भी नहीं, बैठेंगे सब वहाँ पे अभी। सर एक्सेप्ट कर लेंगे सर, यही नहीं। अभी क्या कर रहे हो अभी? सब वो मीटिंग में है क्या सभी?
भाई माइक तो बंद कर ले।
So again, it's 15 past 5, and let's continue our introduction. So I think you all good and understand how you will be learning this subject. LMS, I trust again, if you are new students, you just need to typically know that LMS is the source of all the teaching and learning materials staff provide the student with, and that's how we communicate with you as well, announcements, emails. So get on top of it, whether use an app with your smartphone or make sure your emails are connected there as well. So I think students who have been with us in the course, they are on top of this already. This is just, as I would say, the dates here may not be up to date, but they are kind of the topics I'm talking about. And this, again, with the other details I will be updating, I will update it for you. But basically, this schedule, which is available on your subject learning guide, it is the one we're following, and also this guide is available on your current up-to-date subject learning guide, which I said to you, it is under the welcome subject support. So it's here. You should be able to see all the up-to-date details about the subject. And that schedule I was referring to, it is sitting here as well. Okay, it is available here for you. It's up to you whether you want to use the LMS or you use the PDF. All right. So with the, all right. So we're done with the general introduction about the subject and how it's going to run, how it's going to be taught. Now, as I said, I've just selected a topic which is kind of a reminder for the students about their previous knowledge related to concrete and their properties, just so that will help you to be on top of details or skills required when we think about some of the features we have, which we've got many of them related to concrete. All right, so just a quick review about the properties, the loads we consider floor systems. I won't go through design, talk about the construction side. So, there are a number of properties for concrete and steel, which a construction engineer need to know about when supervising the construction for such elements. For example, here we're starting with, so as I said before and saying now, we do assume students have enough background about the concrete mixed design and all these kind of details. This is just a reminder. Now, basically, with the RC refers to reinforced concrete. I keep saying RC, maybe I mean reinforced concrete elements. They have two type of properties: fresh concrete or wet concrete. Fresh concrete, which is the one we just poured, and also hardened concrete. In the morning, I was teaching design students how we design concrete, right? I was telling them that the hardening properties are the most important ones for you, because typically the engineers, they design the status of hard concrete, if you remember when you studied it at undergraduate level. However, construction engineers, this one is also important for them, maybe even more important than hardened, because hardened, if they build it correctly, it's not their problem anymore. It's whatever the engineer did, the structural engineer. But fresh concrete, it's what you're actually getting supplied with and what's going to happen on site. So you need to make sure they are as per the recommendations required from standards or from the drawings. Okay, so wet or fresh concrete properties, they are like workability, slump test, bleeding, shrinkage, plastic shrinkage, and compaction and curing. these are kind of features where construction engineers need to know about. So any ideas about workability, how you measure it? Slump test and workability, any idea about this?
Sample list is basically to check the workability of the concrete if it's going.
Yeah.
Okay.
That's right.
It is measured by cone during the construction when you're pouring. So a lab technician actually make with a scale, and there is some measurement or something. Yeah.
That's right. So, usually as a construction engineer, you're gonna be ordering, you're gonna be looking to the structural drawings, which I showed you. And after from the drawings, it will tell you this slab requires 32 MPa concrete. Do we all know what MPa stands for? MPa is the unit we use locally. It's a Newton per millimeter square. MPa Newton per millimeter square, and for slabs typically we use 32. So you're going to be ordering that, and then the supplier, whether ready mix or boral concrete or boral concrete, they are the famous ones. They're going to deliver for you the mix. They're going to pour it. You just need to make sure, I know you not be, now remember, as a construction engineer, you're going to be supervising different contractors, and the main role you have is to make sure documentation is there and the proof is there, things have done correctly. Like for the concrete, don't think that someone poured it, they're responsible, goodbye. You have the paperwork for that. You have to be following on, making sure they're going to be pouring the right strength of concrete and the right quality. So when we're talking about slump test, they're going to be doing these tests in front of you, or you make sure you had some certificates. These are the slump tests I was talking about, which one of you briefed me about already. So it's like an inverted cone like this, and they're going to be filling. So they're going to do this on site when they are pouring the concrete. They're going to take some samples, put it inside the cone, then lift this up, lift it straight up, and then they're going to see how the concrete slumps. Yeah. Now, what gonna guide you through whether it needs to be a large slump or a small slump is up to who? Structural drawings. Structural drawings, if I'm still opening these drawings, I'm not sure if it's open. Where are the structural drawings? Why I have this? Yeah, so the front sheet typically will tell you what slump test you need for particular type of structure. I think it's here. No, I think it's, no, it's not here as well. Depends on the project. So this is the concrete strength, right? Which is a concrete strength is the hard property. I will tell you about it as well, how to check for that. But slump should be as well. Maybe it's written within the texts. Sometimes we would have a table like that and talk about it. But anyway, regardless, this is just loadings, which is fine. But maybe it's written somewhere inside the lines here, which we don't need to worry about. So basically, it should be written in the front page here, right? And that will confirm, again, what it will confirm the, let me go back to my notes. It will confirm the workability. You need to make sure you have adequate workability in case you have a lot of bars in your slab and the spacing gonna be too small. In case you had, a very low slump, then maybe it will be difficult for you or for the concrete to go through those voids, small spacings, and then you will end up with gaps. Even the vibration system you use may not really help it. So these kind of things you need to be on top of it. Bleeding, it means that the escape of water from the mix. This is again a side observation construction engineers need to be aware about. You need to make sure when the concrete is poured, the bleeding of water is not excessively happening, on site because that may impact the quality of concrete. You don't need the water to go out from the mix very fast or too quick. You actually want to keep the water. You want to impose the curing process, okay, to make sure the chemical activity is happening slowly. Because if the water is not there, right, then not all your concrete have actually been chemically processed, and you may have very soft spots in your concrete, in your final concrete product, which is a weakness. Okay, and that's right. You can't really. You have to make sure. Again, I think one of you is noting not too fast and not too slow. Which who gonna tell you about these guidelines? Either the structural drawings or the standard. So the standards will give us all these kind of. So these kind of properties, they're not independent, they are interlinked. So for example, some tests will help you to control durability. Curing will help you to control bleeding, shrinkage, plastic, compaction, and I think one of the other ones. There are other ones like vibration, or some people maybe consider compaction as well. Vibration is very important to make sure your mix of concrete. So what I'm trying to say, these properties are dealt with during construction. So that's why I was pointing out they are important for the construction engineers, as well as hardened properties. You are the builder. You may be in case, because if things goes wrong, you need to prove that this strength of concrete was used. So the hardened properties are strength, durability, drying, shrinkage, creep. You need to make sure the strength was correctly built. Now, how are you going to prove this? You're going to be actually, because the structural drawings, which I was showing you here, they actually want for the slabs, what do they want? They want 32 MPa. Yeah, they want 32 MPa. So how are you going to prove this was the case? When the supplier going to come and pour the concrete, you need to make sure, you need to supervise and make sure they're going to be sending you, they're going to take samples from it in cylinders. They're going to break the cylinders after 28 days, and they're going to report to you the outcomes. Because as per the standards, after 28 days, the concrete should give you more than 32 MPa or equal. Okay, so you have it as a proof. You're going to put it with your paperwork and make sure it's all done correctly. Okay. Properties of aggregates used in the concrete. Now, properties of aggregates, again, if you had a slab which has a lot of reinforcement, we need to make sure the slab is actually, you need to make sure. I will just show you an example for slab. I was showing it as well. You need to make sure the slab there, like this is a concrete slab that I've recorded before with a 3D camera. You can see some slabs going to be heavy reinforced. We had a band beam here. There was a band beam, and these are the slabs. So you can see within the band beam, the spacing is very, very small. The spacing of the bars, they go really small. So you need to make sure when you're going to order your aggregates, you have to say they should be smaller than the spacing to make sure the concrete will go through. You don't need an aggregate stuck above those, but between these bars, and then you're going to cause a problem there. Definitely going to have a void at the bars. So it is a failure, right? That's to do with slabs. Jumping back to my slides, where is it? Yeah, what else? Add mixtures. Yeah, can someone tell us why do you think we add mixtures?
Bond it quickly, concrete bonding, and to settle down the concrete more quickly.
So what was the other one?
To settle down the concrete quickly, to bond it quickly.
Correct.
And the
Excellent.
settlement
Yeah,
can be
that's
done.
fine. That's
To
totally right.
enhance the
Sometimes,
properties.
yes. So there are different products of admixtures. You would need to specify and request. For example, if you're pouring an outdoor a concrete slab for an outdoor area, then you need to be careful in having a watertight concrete mix. And to make sure you have the best quality, you can have an admixtures that can reduce the crack size to minimum or eliminate them as much as possible. And that will help you to have a waterproof, or like what they use in swimming pools, etc. Okay. Yeah, controlling a bit more the curing process. You can do this with chemicals. Yes, that's right. You can control the curing process. Now, curing can happen with wet sheets. Sometimes they can have, you want to cure the slab, you can have wet sheets to delay the water evaporation, like what you've just told me. One of you told me. And the same thing, you can control this with some admixtures. So these are the properties which you definitely would need to know about. Concrete production, that's again just a flow chart. Things like this, I will be very clear. I won't be asking you in the final exam, can you, we did not practice it together. I did not say that to you. And that's the key thing where you need to follow me with my lectures and workshops, because I will be guiding you through how you're going to be assessed in the final exam if people are worried about, because I won't expect you guys to memorizing these flow charts. I won't be asking, can you plot for me the process of producing concrete? I won't be asking you this. All right. But in summary, this is just showing you how we start with the materials and we end up having a mixed design by the concrete suppliers. Then we end up with the fresh concrete and we can get into placing it on site. Now, the design and all that is done by structural engineers, as you would know. Placing the formwork is another job, which you also learn about. So before you place the concrete, like that 3D image I was showing you, you know, the black sheets here. Not sure if I can zoom into this. So you can see here we've got black. These are the formwork we put below the slab temporarily, right? Then we put the bottom bars, the top bars. I will be exposing you to these two drawings. Yeah, and we're gonna work on this. You're gonna see top reinforcements, bottom reinforcements. Here, as I said to you, the band beam is running this way, and the slab is running this way. So you can see there's a lot of reinforcement running along the band beam, and for the slabs, they are mostly running across the slab this way. Okay. So after we place the concrete, we follow up the engineer's design and the architectural design. And if there's any environmental influences, like for example, if you got unexposed concrete, you would need to think about using CEM5ACS. Not sure if you know that name. CEM5ACS is one of the admixtures we use in the concrete mix. So it's going to give you a better bond, as some of you mentioned, and almost eliminate any micro cracks. Yeah, usually you don't see cracks. Those micro cracks, you don't see them, but sometimes we still want to prevent them if we pouring concrete outside. All right, so the main references for concrete, they are the local standards which engineers use. Chemical admixtures, if you need to know what's locally implemented. Yeah, there are local standards. And I will be exposing you to a number of their documents. There is an institution named as CEM5ACS, which is Cement, Concrete, and aggregate Australia. It's really gives very interesting, simplified practices for professionals working in the construction industry, not only builders, but also engineers, architects, all of those use them actually. And like, for example, when I'm going to teach you about industrial slabs, I will share with you some documents from those people about how to decide on placing the control joints. Control joints, they are the joints we put between slabs to make sure they're going to work properly. Okay, there is also other practices talking about precast panels. I will share that with you. So one of my personal links that engineers use a lot is this one, CCAA, which got the other documents I was talking about. Okay, driveways, I think they also have good. I think I mentioned the control joints and crack control. They all have them. They're very, very handy. They kind of simplify things so people can practice things effectively. There are some here references about steel. Now here we're talking about the steel which we place inside the concrete, and they come into different types, right? We have the straight bars, mesh. Mesh, they are kind of bars which are pre-welded in the factory. So instead of placing the bar one by one in both direction, sometimes you are able to buy mesh and just put the mesh like 3 by 3 meters mesh. It's kind of save time in doing this. Those bars sometimes need to be hooked, cocked, or spliced. Yeah. Again, all this is coming from the structural drawings. Do we know what spliced means? Or cocked or hooked? This means cook. So when you need to have to specify this bar, you need to make sure it's going to be cooked as shown. That means it's cooked or hooked. Yeah, that's why it needs to be same thing here. We have Z bars. Yeah, same thing here. Some people are answering me. That's right. And at the corner or at the end of the slab, like this one here, like step.
स्टॉन पे छोड़ना था हो गए थे कि 5 5:30 होगा उनके साथ ही अब उधर आड़ा रहा आते नहीं था
Yeah, so I think that's what we mean with cogged. I think this one here shows you in general. Have a look here. See the top bars here, we cog it at the end. We cog it at the end. That means cogged. If hooked, we don't use them a lot. They are like this. We use them with the stirrups. Hook. This is called hook. And where is it? I think we have stirrups here. Here we go. Yeah. This is still cogged sometimes, but hooked is more expensive. It's like this. If we do it like this, what's the difference? No major difference. Okay, so the thing is, this will be a bit longer because you have to go with 12 times the diameter. So this is really to do with design, which I don't want you to bother. I just want you to know the terminologies. That's all. Okay, back to our notes. Tolerances and bars, spacing. So there is always acceptable limits that you can go above or below when you place these things. Concrete cover, very important property to handle very well. Concrete cover means it is the spacing between. I think I can look at here. The concrete cover is the distance between the top of the concrete and the side of the first bar, whether top or side bar or bottom bar. This is the cover. This is the cover from here to there. That's what we mean with cover. And over the weeks, I will show you how this is actually looked after and actually done in the projects. We have chairs. All right. Remember here, we're just exposing you to, it's an introduction. No, it's concrete cover. It's not clear cover. It's concrete cover. When we say concrete cover, it is the distance between the outside of the concrete and the steel, the side of the steel. All right. These references talks about detailing. Detailing is the details I showed you, like how you cook things, how you lap things. Lapping, again, I can show you a quick example. When you are, sometimes, typically your steel bars cannot be longer than 12 meters because that's how long the trucks are to transport it. So sometimes if you have very long slabs, you have to lap them together. And when you lap bars together, they have to be within what the standards allow you to do, like 50 times the diameter, 50 times the diameter, right? So they are just features. They are given to you on the documents, whether drawings or standards. As a construction engineer, you need to know what to do. I'm not asking you, I won't be asking you to tell me, I want to make sure you know how to read them, okay? I want to make sure that you know how to read them and what do they mean. But you're not supposed to be knowing it is 50 times the diameter. You're not supposed to know, because that's what the engineer is going to tell you. The engineers usually will say that, here we go, it's here. See lap? And that's where lap L is. So if it's N12 that bar, it's given to you. 16 is given to you. But you need to know what does it mean. That's what I mean with lapping the bars. Yeah, schedulers. Schedulers means, you know, after you're gonna receive your structural drawings, you won't be taking them and straight away go and dig and build. You have to have a steel scheduler who usually works for the steel supplier. They will be making shop drawings. He will be saying in details how many bars are required, how many of them gonna need to be cogged, how long they are, how many laps are required. So it is a bar bending scheduler. I don't know what you mean bending scheduler. He's just a bar scheduler. Their job is to calculate and count how many bars are required for your project. Okay, and he's just gonna be working for you basically. But to have a quality process, you don't need to. You have to get it be done right. Make sure you don't over supply or under supply, because if you under supply, it's gonna cost you time. If you oversupplied, you already costed your project. Why did you waste? Yeah, so you would rather make sure there is a steel scheduler to calculate how many bars are required, how many of them need to be cogged. You know, everything should be done in order, and people do this very well typically to make sure nothing goes for waste. Now, talking about the properties for the bars. The bars, they have different shapes, different strength. As a practicing construction engineer, you need to make sure it is done as per the drawings. Okay, everything is given to you. As a construction engineer, you're not supposed to be designing or guessing or assuming. All right, now in the market, there are different shapes, different strength. Ideally, the strength for bars, it is this one, the one I'm showing you, blue, 500 MPa. In terms of shape, they can be rounded or deformed. Typically, what we use is the deformed. It's got those features to make sure the bond exists. Yeah. What else I would be talking to you about? Ductility. In the market, there is for earthquakes, which for high-rise buildings, there is low ductility and there is normal. Typically, we use normal. So the bars are referenced with its ductility and its diameter, which we're gonna be seeing over there. over the examples. Now, as we said, they got size. Yeah, see here, this is how the ideally, well, typically we actually call the bars by N16s. That's all we say, because typically somewhere we written they all deformed and they all 500 MPa. We don't change this much. We don't change the deforms and the grade of concrete. We just change the size, obviously, because usually for slabs is different than the band beams, is different than the columns. So we keep changing the size. All right. So this is the last two numbers. They are the diameter. This is the diameter. It's 16 diameter bar, normal ductility, deformed, and 500 MPa strength. As I said to you, the length, they can be limited and they can go up to, they're telling you from 6 to 18, some of them to 12. And that's what limits your lapping. So that man, the scheduler, he will figure out where he can stop and how many laps you're going to need. Okay. What else? I would just want to, yeah, these are just kind of information which will let you know about the different type of steel available, the parts that we're going to be exposed to over the weeks. I'm trying to stop at and talk to you about. So there is a different for different bars, which will give you different strengths and features. All right, that was about the properties, loads, and construction concentration. So the engineer, when he designed, the structural engineer, when he designed, he's gonna look after safeguarding and stability and safety and all that. And that's again your role. When you build something, you need to make sure it's gonna be stable, static. You're gonna achieve all the safety requirements intended by the project. You're gonna achieve the serviceability requirements, the aesthetic, the economic side. And look, remember, builders, if you know or not from the industry, they hold the highest responsibility in producing, because he got the highest piece of cake in this whole project. You know, and you know, and the construction bill is the highest among all other consultancies. So they are paid most of the construction fees, right? So that means they need to oversee all those requirements. So what I'm trying to say, structural engineers, maybe they look after safety and serviceability, but they don't care about the look of it. So the builder then need to make sure he's going to be clearly communicating things between the architect and the engineer, because the engineer will be worried about having a safe, stable, does not deform a lot, and that will make his intended aims at. But maybe some of his design does not match the architectural intent. Then you're going to be in the, you have to be the one to work, you know, to communicate those two different consultants to get to the right decision. Example is one of those examples we're going to be working together on. Like, for example, deciding, this is a good example, deciding on the shape of the precast panels. This project you're going to be working on it. You see this one, this shape here, this is one panel, right? This is another panel. This is another panel, precast panel. Now, for the engineer, he may be doing them differently. He may think about doing this whole piece in one go and this other piece in another go, because it's easier for him. As the builder, you are the one who need to know whether this is going to be acceptable in terms of aesthetic, because these lines going to be exposed to the street. Maybe the architect don't like it this way. It will not have that consistency they like. That's one. Another thing, you know, these precast panels, typically they're going to be craned, lifted up and down from a truck onto area final. As the builder, you're going to know what's happening on site. You will know if there are, like, for example, power lines. You know, power lines, they can be up here in the sky. If they are there, it's going to be challenging for you. If the engineer decided to make this panel that long, you need to make sure they will not clash with these lines, because alternatively you have to lift this panel all the way over what? The power lines. So you need to make sure you're going to hire or at least code for the high expensive crane. These are the construction, like simple or few. I mean, there are plenty mistakes, but if you assume that the placement of those panels is straightforward, no, sometimes you're going to find there are power lines and these panels are too long, right? So the question is, how are you going to crane them over the power lines? Maybe you haven't planned for the large crane. Maybe that crane going to be as large as you're going to need a permit from the council to close the road. So see how things go. And in the assignments, I'm going to be asking you to do the questions really like to ask you about considerations. Remember this word. You're going to be asked many times about, tell me what considerations you need to think about when you're doing this and that and this. And the ones I'm telling you now is some of the answers. And we're going to talk about this Wednesday when I start giving you kind of. So this is what kind of the way we're going to be asking you is considerations, right? And some people really don't answer that. They just go talk about something else. They talk about precast, like the history of building precast panels. I don't want that. I'm not asking you to give me a report about precast. I'm asking you, as a builder, what you need to consider when you're going to be constructing them. And I've just already now told you one of them, right? So that's what I'm telling you. Attending workshops gonna give you build the good understanding about the construction techniques. Maybe in a textbook you won't find these things. All right. Yeah, I may talk about something else. So let's go back to our lecture notes. I've given you a strong example about aesthetic and economical. Loads. This is, I can tell you, if people done engineering, they're going to say it is the engineering job. Full stop. Agree with you. The only thing you need to make sure is when, make sure in doing is when you're going to be putting loads on your slab during construction, make sure they don't go above what the engineer assumed. Okay, because sometimes if you're building a hospital, for example, you want, for example, to build maybe some precast panels. And imagine that you're standing on a built slab already, like it was a basement car park slab, and on top of it, you want to build a wall. So your crane have to move on top of a slab you built a few months ago or a few weeks ago. Then you have to be careful in making sure if that crane can actually physically stand on that slab or not. So that's why loading are, yeah, you need to know about them. But as an engineering design, you know, loads can be vertical loads like life load and dead load. And we have horizontal loads like earthquakes and wind loads, etc. Okay. All right, look, I will stop shortly. They are very generic information. We may continue them because during the workshop, I typically use part of our first workshop to talk about these general skills and information. So we should be able to stop soon. And during the first half of our workshop, I will be completing these notes. I will just highlight the skills that you will need to use during the semester, right? There are some general information which I kept there for you, just if you like to scan through them. They may be very simple. Continuing to talk about, okay, so one of the two things you need to understand about loads, some of the loads, they are action load, like what we talked about. So dead load, yeah, dead loads, they are they are there, they are active. Life loads, you know them. They come from occupants, vehicles, if we're doing a car park. Horizontal loads, we talked about it. Some of them are non-load actions, but they can they impose some issues on your structure, like corrosion, right? Like severe local cracking, right? Like differential settlements of footings. Yeah. This one can happen a lot locally if you got trees around you. You know, the trees typically can suck the water, and when they actually trees, they especially unmature or unmature trees, they can suck the, especially in dry season, they can typically suck the moisture from the soil, and that will cause when the soil gonna get dry, they're gonna be some minor movements. But usually this will happen only in light structures. They won't happen in heavy structures, because heavy structures will be difficult to cause that settlement and movement. It can be easily controlled by the system above it. Okay. You know, change in temperature and humidity, they all can have impact on our structures. But for you guys, this is typically controlled by the structural engineers. But during construction, you need to be aware about it. So you need to know if you're building something like those portal frame, and you are building in December, sorry, if you're building them during December and January, in some of the years we had 40 degrees. We reached 40 degrees, and we did notice that a lot of steel work have expanded. So those portal frames we're going to be talking about in our first workshop, first assignment. I'm going to talk about how connections are done, which one built first, etc., etc. So imagine that if you placed your columns, and if you had your roof rafters on ground waiting for another day, and you had those heavy or high temperature weeks scanning through, then expect that you have few millimeters expansion, which will end up changing the dimensions of your structures. But these things typically can be looked after in different techniques, and I think the industry knows how to deal with it. Okay, so let's stop here. Let's stop at load paths. We do have maybe some decent number of slides to go through. I will be just scanning through them. Again, some of them, they just to prepare you for the coming applications, but you don't need to memorize the skills, heavily memorize the skills we're talking about. But I just want to remind you about the different framing techniques available in different types of buildings. So let's mark it at the load path. We'll stop my lecture here, and we'll use the first half of the workshop continuing these slides. Then the second half of the workshop, which will be on campus for Bandura, online for Bendigo. I will use the first hour to continue these slides, and the second half will introduce the assignment 1, and we'll also give you some time to start the grouping. Yeah, so I will start the grouping, let you start the grouping even before the workshop. I will, in the morning, if you entered LMS, you will be able to jump into those rooms I talked about. And then I think that's it. Maybe I have time to answer a few questions, to help you with a few questions, and we'll continue over the coming weeks. Okay, is there any question, any comment? We can relocate the power poles. Oh, it's gonna be too lengthy. Someone is suggesting we can relocate power. You have to wait 4 weeks to get approvals from the power authorities and all that. Well, I can tell you some people would reject you're gonna, all these kind of approvals, it's gonna need months and months to get them done. So yeah, you need to think about it beforehand. By the truck, how do they transport mesh of steel bars? All right, let me show you how the mesh of steel bars look like just by truck. Yeah, just by truck. I think this is the best picture that will answer your question. Does that make sense? So these are the meshes I was talking about. They come 3 by 3 or 2 or whatever, and they kind of tack welded. They tack weld them together. Yeah, these are tack weld, and they will just put them on spot. Was that your question? All right, so that's how they do it. Yeah, definitely they won't do it wider than possible because Vic roads will give them a big fine. Remember, these kind of meshes, we can't do them for heavy bars like N16s. We typically do them for N12s and smaller, just for your information. N16s maybe, but N20, N24, like 24 diameter, they're going to be too heavy. They can't do it. They only do it for light steel bars. Okay, guys, was good to meet you all. Yeah, now they won't bend it. That will cause, as you said, residual stresses. They won't pre-bend it. All right, guys, so that's it for our first lecture. Let me stop recording, and it will be available in LMS. I will